Welcome to TechBrothersIT. In this video, we are going to learn about cache in PySpark. Cache is a PySpark optimization method that stores the data frame or RDD in memory. So it's in the memory of executor node. After the first action triggers is a computation. So now it avoids recomputation of the data frame for subsequent actions, improving the performance. So once the data frame is in memory, you can reuse it so it doesn't have to recompute every time. Here are some key points. Stores data in executor's memory, not in driver's memory. So just I wanted to make this point because it helps to understand where exactly that memory is used. So it is in executor node's memory. Okay, lazy evaluation. Cache takes effect only after an action. So once you will say df.cache, you put the data frame in cache, you have to at least run one of them, like .show or .count or something like that. So at least once you initiate one method or take action, that's where the data will be in the memory. If executor memory is insufficient, Spark may evict partitions and recompute them. So that's also important because sometime maybe your executor node does not have enough memory. So in that case, it will evict the partition, and then recompute as well. So whatever the needed, it depends upon the memory availability. Now cache is a shorthand for persist and storage level, memory and disk. So if you see right here, so in case when you are using cache, and let's say you have some memory available, the data frame will be in the memory, but if the data frame is too big, it will not fit into the memory. What's going to happen? Then the rest of the records will be going to the disk and they will be written to disk, and that's how it will be done. So in the next execution, whatever is available from the memory, it will be used, and also the data will be read from the disk as well, but still faster as it will try to use most of the data which is available in the cache. So why use cache? What are the benefits? Speed up jobs when reusing the same data frame. So that's important. So if you have a data frame and you need to run multiple jobs, or in different jobs you are using the same data frame, this is a good point to put the data frame in cache. Save computation time in the iterative algorithms such as ML graph processing. So in those cases, that's also helpful because you don't have to recompute every time. Useful for exploring and or data analysis, so that's also helpful. Optimize performance in joins where data frame is reused. So if you are joining your data frame with the other data frames at different time, it is helpful, and you can use multiple joins at different times. Once the data is in cache or in memory, that's easy to grab quickly and use with other data frame in joining and all. Now here is just a basic architecture. So you have a driver here, driver node that send tasks, and there is no caching on the driver side. So on the executor nodes, what's happening is it execute tasks and it cache data in memory. So that's what happened. So the executor nodes, they will save the data into the memory. Okay, so here we are creating the Spark session, and then here is my sample data. I have ID, name and age, so very small data set, and here are the list of the columns for this specific data. Now I'm creating a data frame here by using create data frame and using the above data and the column list for my data. So now our df will be data frame will be ready, and now we can display. Nothing really fancy here to show you because it's just a simple data frame that I'm creating here. If you go further down, you will see we are just printing the data frame right there. So ID, name and age. Now what are the next steps for us to see? So cache the data frame. So how you do that? You will say df.cache. So once you apply that, what's going to happen is going to put your data frame in cache. So you execute, but you have to trigger at least one action after that. Once you do that, trigger an action to materialize the cache. So df.count. Once you do that, then it will be all good. Now anything after that you are going to run, this data will be data frame data will be coming from cache. Now after the first action count, in our case, Spark stores partitions of the data frame in the executor memory. Future actions reuse the cache data. Just so I have explanation here as well. Now performing some action on this cache data. So df.show, this will, if I will execute this, what's going to happen is going to run or get the data from the cache. So that's going to be quick. In my case it's 4 records, so it's not making a whole lot of difference, but if you have a large size of data frame and this is in cache, you are going to see the difference instead of recomputing every time or coming from the cache. Here you can use filter, so same df filter and df.age greater than 28 years, so you can do that. Then you can use group by if you want to do that. So all these complex queries can be written as well, so very easy to see how exactly you can use it. There is no difference really when your data frame is in cache or is recomputing. It's just the time of processing. So if the data is in cache, you have the same data. It's not going to make any really difference in the data or rows or all that, so because it's the data frame in the cache or memory. Okay, so we got these results. In our case the queries are the data is so small, so it's not like I could have shown you running the query and computing all the data and then showing you, and then I will say like, oh, it took 3 minutes, or here I ran in from the cache, it took like 20 seconds. So I cannot do that because my data set is so small. But you can test in your case and see how exactly it is performing better when you put the data frame in cache. Now if you want to check if the data frame is in cache, so you can always go and print this out. df.isCached will give you true or false value. So here it is. Right now we can see that this data frame is in a cache. Now once you are done using it, you want to free the memory, you will say df.unpersist. So this action, what it will do, it will just remove your data from the cache. Okay, now it's done, and you're not seeing anything like it is removed and all that. But to confirm, you can always run the same query again, but we have run df.isCached, and the same one, it should return us a false this time. So if I will go here, and you can see that it is returning me false. So you can see if your data frame is in cache or not. Now here are some points or real-time scenarios I added. This is the same points I actually have spoken above. Reusing data frame in multiple actions such as transformations, analysis, workflows, repetition, filtering, grouping, ML pipelines with repeated training, data access, repeated joins in lookup, and with the same lookup data frames, and then you have all those other best features. I also have run some notes here for the best practices. So trigger an action after cache to store data. So remember that we have, once we put the df.cache, then we had to run df.count or df.show or any action that will put the data into the cache. Monitoring Spark UI, go to story tab for cache status. You can do that as well, and then use unpersist to remove the data from the cache. Use persist if fine-grained control disk memory is required. So in our case I use cache, and if you remember that with the cache it is memory and disk. So if the data is going to the memory is full, now it's going to go to the disk. So that's the one of the reason you will not be getting a issue, out of memory issue. So avoid caching large data frames unnecessary to prevent so that's the out of memory issues. So if you are just trying to put everything in memory, it might not fit, and this the data set is so huge, or data frame is so huge, so it will give you this error. So in that case you can use cache that will also use memory and disk. So there are different settings for the persist, but if you are using cache, it uses the settings here I had it actually. So it was memory and disk. So that's the setting the cache use it. So it try to put whatever it can put in the memory, and whatever doesn't go in the memory, then it goes to the disk. So that's pretty much it, and then at the end I have this point. So use where was it? Avoid caching large. Yeah, we have done that already. And here is a summary, just so I will put these notes in the description, so you can kind of test by yourself, and it will help you to understand how exactly cache make a difference in running those queries or the commands when it is recomputing everything every time, or when the data is in cache and you are reusing it. Okay, one more thing I want to talk about, that monitor Spark UI storage tab for the cache status. So that we didn't cover. Let's cover this part. So once we execute, so we want to see how many partition, how much data and everything is saved into the memory. So we want to see and take a look. So now what I'm going to do from here, let's say if we put in a cache and then initiate it, and we can run some queries if you want, these below queries, or even just leave this as is. Okay, so once I execute this part, now what's going to happen, we are going to go ahead and check the storage. Now we go to compute here, and in the compute, once you are in the compute, it's going to show you the cluster, right? So here's my cluster, and I'm going to click on cluster, and in the cluster you're going to go to Spark UI, and in the Spark UI then it's going to open that detail. You're going to go to storage, and here in the storage you're going to see that right there. So ID 179, that's the unique identifier for our scan cache to RD or data frame, and here's the name for that one. You can see the ID, name, and age. So we can see from here, these are the column we use in our query, or a data frame has those. So if you remember that we have ID, name, and age. So here is the storage level. Disk memory deserialized, 1x multiply replicated. So this tells you like how exactly the Spark is storing the RDD or data frame. So how it is doing it, this is the answer for it. So it is a cached 4 partitions, and the partitions are the units of the parallelism in the Spark. And now fraction cached, so 100%, so all the data it was able to cache, no problem at all. And the size in memory 2.5 kilobytes, and size on the disk there is 0. So we don't have large size of data frame, that's why nothing went to the disk. But if I will have like 4 GB or 6 GB data, there would be chances like, okay, whatever fits in the memory that will fit, because my Spark nodes they don't have more than 4 GB memory. So then the rest of data would have gone to the disk in this case. But in this case, this is so small, so everything fits right here in the memory, no problem at all. So that's how you will see the detail, how much is cached, what percentage is cached, how much is in the KBs or MBs, and then how much is went to the disk. So this helps to analyze about your data frame, how much space it is taken in the memory, and how often you are going to use it, so you can make sense if your nodes are able to handle or not. You might want to increase the memory, and just in those kind of scenarios as well. So I thank you very much for watching this video. Please subscribe my channel, and I will see you guys in the next video.